Everyone, I hope you all are doing great. My name is Anjali and I'm currently working as SDE2 at Microsoft and I'm an educator at Relevel by Unacademy. Our today's topic is process synchronization. So let's get started. So in this particular one, we are going to be discussing about the various process in synchronization, the various ways of doing it. So you know what is that? I'm actually going to be sharing my screen and based upon that, I'm going to be talking about it, and also I'm going to be providing you some of the notes which you can just find it handy for your purpose. Okay, so let me just share it. Yes, so our topic is process synchronization. So what is the actual meaning of the word synchronization? Let me write down process synchronization. So whenever we are going to be talking about synchronous, that actually means something which is going to be following some of the order. So you know, in this particular one, what was actually happening, like if I have to talk about process synchronization, so what is the process synchronization? So this particular one is actually used to handle the problems which come up when we are having multiple processes and all of those processes are running together. So let us say we have some processes P1, P2 up to Pn. Let us say all of those are working together. So what is going to happen? Obviously, we are going to be facing some of the scenario where we will see that they are not synchronized. So in order to handle such a problem, your process synchronization was actually introduced. Okay, so we can say for process synchronization that it is used to handle problems that arises when we run multiple processes at a time. All right, now for this particular one, when we talk about these things, so like I'm mentioning, we are going to be having various processes available to us. So you know what is going to happen? There will come a point where like there will be two type of situations. So in one of the situation, even if these processes are running together, they are going to be independent of each other, and that particular one we call it as independent processes. So in independent processes, what happen? All of your processes are going to be running independently. They are not going to be dependent on each other. So that particular one we refer it as independent processes. So let me just write down the two types of processes which we have. Independent processes, and the another one which we have is the cooperative processes. So now what do we mean by the cooperative process? So you know, when you are running any of the process at that particular time, if they are going to be dependent on each other at that particular time, we refer to them as cooperative processes. Now I will be writing down about both of them. Okay, so what is the independent process? If the execution of one process does not affect the execution of another one when they are going to be running independently. So that particular one we are going to be calling it as independent processes. Okay, so independent process. So when execution of one process does not affect execution of another one, if they both run independently, or we can say if they both run independent to each other. So those particular processes we are going to be referring as independent processes. Now the next one which we have is the cooperative processes. So if the execution of one process is affecting the execution of the another one, so that particular one we are going to be calling as cooperative processes. And in such a case, you actually need to synchronize your process. So what is the meaning of synchronization? Like in such a case, since one process is going to be affecting the execution of the another one, so you will have to ensure that if you are running one, so that is completing its execution, then only the another one should start its execution. Otherwise we are not going to get the proper output, and there will certain situations are going to be arising. That one we are going to be covering in the next topic. All right, so your cooperative processes. So if execution of one process affects the execution of another one, if execution of both processes are dependent of each other. So in such a case, what we are going to be doing, we are going to be providing the order of execution to them. So the processes needs to be synchronized. So we can say in such a case, the processes must be synchronized to the order of their execution. All right. Now we are going to be covering our next topic, and what the next topic is going to be there. And before that also, like one more thing which I really want to add here. So that is, like let us say you are running some of the processes, like since I have introduced this word synchronization here. So what is going to be happen when processes are synchronized? So at that particular time, what is going to happen? If you are running one process, you will ensure that this has completed, then only you will be starting the another one, so that we are not affecting the execution of the one another. And here we have actually spoken about the two types of processes. Now let's discuss about the process synchronization as well. So what the process synchronization actually does? So in that particular one, we are going to be coordinating with the execution of the processes. So when we are going to be coordinating with the execution of the processes, so what will happen in such a case? Like let us say we have some shared resources. So let us consider the scenario that you are having some keyboard, you are having some printer, mouse. So all those are the limited resources which we have. So what we will do, let us say at a time, if you are not using your keyboard, we will assign it to somebody else to use it. Similarly, like I'm just giving you some scenario, I'm not saying a feasible one, I'm just trying to explain you how does it actually work. And let us say you are not printing out something, so at that particular time we will allow some other user to use it. So all this, how are we actually managing it? With the help of process synchronization. All right, so let me just discuss about it. Process synchronization. So what is your process synchronization? In this particular one, what is our major task? Our major task is to provide, or what you can say here, our major task is to provide some order of execution. So here what we do, if we want to execute some of the processes and in some definite order, so what we are going to be doing, we are going to be coordinating with the execution of the processes. So we can say here the task is to coordinate the execution of processes. All right, so here we are going to be coordinating with the execution of the processes, and when we will be coordinating it, we will ensure that no two processes are actually sharing the same resource at the same time. Let us say you want to print something and a user B also wants to print something. So in such a case, we cannot actually, like, nobody can actually complete it. But what we can do, if we are going to be assigning it in some a way, in such a way that, okay, one is completing it first and then it is going to be get assigned to the second one, in such a case the execution will complete and at the same time both can complete their task. So what we will do here, the task is to coordinate the execution of the processes in a way that no two processes, sorry, no two processes are having access to same shared resources. All right, and in this particular one, what is actually going to be happening? So just provide the order of execution. That is what is important. So what we will do, provide order of execution. So in such a case, you will have some definite order, and if you're going to be following that order, you are going to be having a very smooth execution of your entire process. Also, what we will be doing when we are saying that we are going to be providing the order, so that one is nothing but synchronizing them. So when you have to synchronize your task, when you have to synchronize your process, so what you will be doing, you are going to be following various synchronization techniques which are going to be available to us. All right. So we can also mention that we have various synchronization techniques available to us. All right. Also, when we talk about synchronization techniques, so that one is going to be coming under your process synchronization. So like when we are like, what is the actual need of process synchronization? That we have the multiple processes which are running at the same time. So what we can say, process synchronization is actually required when you are having multiple processes which are actually running together. If that was not the need, we actually do not require any process synchronization. But when do we require it? When we are going to be having multiple processes and all those multiple processes are running together at the same time, and what they are actually trying to do. So we are going to be having certain shared resources, and those processes are actually using those same shared resources, because in such a scenario only we have the need of synchronizing our processes. All right. Now, there is like what I was actually saying, that let us say you want to use a printer and at the same time somebody else also wants to use the same printer. So what will happen in such a case? You are actually coming in a state where nobody can go ahead and complete the execution. So what is that situation which we can call it here? That one is going to be called as race condition. All right. So let me just write down race condition. So what is going to be there in the race condition? So when you have more than one processes at the same time, and if they are trying to be accessing the same memory, or they are trying to be sharing the same shared resources, and like in that particular scenario, what is going to happen? So the possibility is there that the values are going to get wrong. So like, let us say, I'll give you one more example. So let us say you have a document A, you have a document you have a instead of that, let me just say you have a document and you have a user A and you have a user B. So this user is going to have some read write permissions. All right. So reading the document, writing the document. So if we are not going to be synchronizing it, what will happen? Let us say this user is also writing, this user is also writing, so they will write something. And at any point, if we are going to be looking at it, what we will see, the output is not correct. So let us say this person is writing something and deleting something, and that whatever A is writing, B is deleting that. So what will happen? You are not going to be getting the correct output. So in such a case, what we do, even though like they both are running together, so they both will actually try out to actually show that we are running correctly, we are providing the output correctly. All right, so when there is a condition, when they both are running together and they both are actually going to be providing the wrong output, so in such a scenario, what they will do, they will keep on trying to prove themselves right, that whatever the output is there, that is perfectly right. And that particular scenario, we refer it as race condition. All right, so that particular one, like if anybody is going to be asking you about what a race condition is, so with the help of this, you will be clear about what a race condition is going to be there. All right, also like there are, there is going to be a situation where we have lots of processes, and all those processes will keep on trying to access and process the manipulation of the same data. So what is going to happen, like the same scenario, that they are there and they both are actually trying to access the same type of data. So in that particular one, whatever the output is going to be there, that is not going to be correct one. And this particular condition, like when we have a race condition, so we say that we are going to be coming in a critical section. All right, so we can say race condition arises when we have a critical section. All right, so in this particular one, what is going to happen, like if you want to actually get rid of this kind of situation, so we are going to be having a critical section, and in that critical section, what we will do, we are going to be providing some of the resources there, some of the processes there, and we will ensure that if something is there in the critical section, in such a case, no other process can enter it. So what we will do, we are going to be providing some of the order, and based upon that order, we are going to be ensuring that we are completing the entire execution, and that too smoothly. All right, so we can say race condition in the critical section happens when your multiple threads execution differ. So we can say critical section or race condition in the critical section happens when the result of multiple threads execution differs according to the order in which the threads execute. So now this one is going to be giving you clarity that what is your race condition. In that particular one, we are going to be having a critical section, and obviously if we are having a critical section, we are having a race condition, so obviously we have some multiple threads, and all those multiple threads are trying to having an execution, and that execution is going to be differing based upon how the threads are actually synchronized there. All right, but also we have to but also one more thing is there, that is this condition is the critical section. Like what we can do in such of a condition, we can avoid if the critical section is treated as the atomic instruction. So what actually happen in the atomic instruction, more than one can enter. All right, so your proper thread synchronization actually locks or atomic variables that can also prevent your race condition, because at the end we are going to be targeting avoiding such a scenario. Okay, now I'm going to be discussing about critical section problem. All right, so now what is your critical section problem? So let us say you have various processes available. So let us say you have processes P0, P1 up to Pn minus 1. So total processes available to us. All right, now let us say every process is having a segment of code, because all that code only these processes are trying to execute, and that one we can say that particular piece of code we can call it as a critical section. So in that particular one, what is going to happen, processes will be exchanging common variables. So these processes must be using some of the common variables. So what can happen, probably one process can update the value, one process can maybe just delete it. All right, so that thing can actually happen. So what is actually going to be happening in such a case, we can say you are actually executing these processes, and when you have to execute these processes, we will ensure that we are having a critical section. So when we will have the critical section, so we will ensure that if one process is there in if one process is executing in the critical section, then no other process is allowed to execute in its critical section. So that is what we have to ensure here. So we can say if one process is executing in its critical section, then we will ensure that no other process can enter the critical section at the same time. All right, also what we can say, if we are going to be having a critical section, so obviously when we are going to be executing them, so we will ensure that these are mutually exclusive all the time. So that is one of the property which you will have to ensure at the time of execution of the processes. So we can say the execution of critical sections by the processes is mutually exclusive in time. All right, also in this particular one, what we will say that if some of your code is going to be there which is running in your critical section problem, so what is going to happen, no other code can actually come and execute it, and we are not like, if they want to perform the execution, so they will actually have to request for the permission to enter in that. So what is actually going to happen, we are going to be having one segment, some section we are going to be having, which is going to be actually taking care of all these requests in the entry section. So once they are going to be approving it, then only that process can actually go ahead. So what we will be having, we are going to be having one place where we have all the requests. Also, we are going to be having one entry point for the critical section, and we are also going to be having one exit point. So what and all we will have, so we have some entry point, we have some request point, we even have something like exit point. So here we will be having all those requests, plus we will have one more section which we will be calling as remainder section. So what will happen, whatever your remaining requests are going to be there, so that particular one are going to be coming in your remainder section. So those ones who are not going to get the permission of executing it, so they are going to remain in your remainder section. So this is how I have drawn the certain blocks. Now I will be showing you in the form of quote. Okay, so how it is actually going to be there. So I'm actually using a do loop. Here we will be having something as entry section. After that we have critical section, and like I mentioned, after this we need to have something like exit section, and after exit section we will have something like remainder, because once we are entering in the critical section we need to exit it, and then your remainder section is going to be coming into the picture. So here we will have exit section and we will be having remainder section. All right, and this is your do while loop, and this will keep on executing unless this loop is going to be true. All right, so now let's talk about all these sections. So you know what is this critical section? So this is the critical part. So we can say what this one is. This is your critical part. Now what the remaining section, this remainder section is there. So this particular one is going to be having rest of your section. So we can say rest of the section. All right, and now we are going to be talking about this entry section and exit section. So when you are going to be entering here through your entry section, so what we will be doing, we are going to be locking our resources. And why are we performing lock on our resources? Because we will ensure that at that particular time nobody else can actually go ahead and use them. So what we will be achieving here, we are going to be controlling the entry into the critical section, and we will be performing lock on the required resources. So we can say for our entry section that we are going to be controlling the entry in the critical section. So we can say controls the entry in the critical section, and we can also provide a lock on the required resources. So we can say and provides lock on the required resources. All right, after that we have something like exit section. Since if you will see in the entry section, what we are doing, we are locking the resources. So when we will be in the exit section, what we will be doing in such a case, firstly we are going to be removing the lock, and in that particular first let me just write down. So what we will be doing, remove the lock from the resources. All right, and what is the next thing which we will be allowing here? We will allow others to know that the critical section is over, so that they can come ahead and place the request to enter in that. Okay, so we can say and let the others know that its critical section is over. So I assume with the help of this, you will actually develop the understanding about how the critical section is going to be executing. All right. So what and all do we have here? Firstly, we have the entry section, then we have our critical section, then we have exit section, and at the last we have remainder section. So your entry section is actually going to be controlling the entry of your entry in the critical section, and it is also going to be providing lock on the required resources. Then you have critical section, which is actually your critical part. Then you have exit section, so it is actually going to be removing the lock from your resources, and it will also let the other people know that I have exited from there, and once if they will know that, so they can actually come ahead and place the request to enter in the critical section. And your remainder section is going to be having the remaining sections, whatever you are going to be having. Okay, so now let us discuss the next thing. So what is the next thing which we have? That okay, we have discussed about the critical section. Now we should be discussing about the ways we can actually solve that. Okay, so our next topic is going to be solution to critical selection problem. All right, so here what and all we are going to be having. So what is the solution here? So the first solution which we have here is the mutual exclusion. So the first one which we have is mutual exclusion. So what is the mutual exclusion doing here? So this particular one is actually see that, okay, if one process is there in their critical section, so it is not going